In this video we want to look at a very important skill, which is how to anticipate. In particular, when you're answering test questions or solving problems in the real world, anticipating will spark the right creative parts of your brain, get your intuition working to help you solve the problems. There's kind of a mysterious gap between having a problem posed to you and then finding the correct answer. Where when you anticipate, you're looking into that gap and trying to imagine what can fit in there. So what I wanted to do is go through this question from level 2 physics. That's the year before final year of high school and for international viewers. And I'm not actually going to try and answer the questions, although that might happen. I'm going to go through and just discuss this anticipating strategy. It's very, very important. Okay, so here we go. Anticipating and commenting on how I answer the questions and giving you some ideas to do the same. If you have ideas as well that I don't cover, please share them in the comments. Here we go. First thing I'm going to do, I'm going to read the question. So I'm going to read, and when I read, I'm going to be thinking about the types of physics principles involved. I can already see some circles, so I'm thinking there'll be circular motion, which is a subset of mechanics. So I'm going to go through this anyway. Question 1, throwing the discus, part 1. James is preparing to throw a discus by swinging it in a horizontal circle. That's the diagram down there. Okay, and with the circle swinging, I think I've confirmed that yes, it is circular motion. The diagram below shows the path of the discus moving clockwise as seen from above. So just thinking to myself as I go through this, a clock runs its face around in the direction of this arrow. If I was to draw hands on the clock at 2 o'clock and then 3 o'clock, and that's what's going to happen. Okay, so a clock definitely goes around that way. The diagram below shows the path of the discus, we've said that, and what I'm doing at this point is I'm starting to think of important factors. So I've noticed there's no radius drawn on this diagram. I'm thinking about formula that might be involved. I'm thinking about, just because questions like this always come up, I'm thinking about where this discus would go if the person in the middle throwing it let go at this point. And I'm thinking it would go off at a tangent to the surface, perpendicular to the radial direction that it's going in, because that's where the instantaneous velocity is going. So I'm thinking all of these things, not as detailed as I'm saying now, but they're popping into the back of my mind, just saying, okay, that's related, that's related. And one thing I'd like to say in a little bit more detail is you have this kind of category of physics. Under physics you have like mechanics, you might have electricity, you might have atomic and nuclear physics and optics. I'm narrowing down, I'm making a conscious choice in my brain to narrow down to mechanics subset and then to circular motion. Okay, and why I'm doing that is all of the rest of this diagram in my mind of all the physics principles, that's clutter that interferes with my thought processes. So I'm narrowing it down, bringing focus to the way that I'm answering the question. I'm trying to eliminate all of that extra chatter. It's like if you're sitting in a classroom full of people and someone turns some music up. Well, okay, I was sitting in your bedroom and you're trying to answer a question or talk on the phone or think about how you're going to reply to a text, and someone's banging on the door, or you've got music up really loud, or there's a police siren going on outside, and combine all of these things together and you have a really hard time concentrating on what you're trying to do. So it's the same thing, but in the back of your mind, in your subconscious, in the part that's kind of throws information out for you to go aha, and you realize that the back part, that stuff can get cluttered as well. So you want to be bringing clear focus. Anyway, moving on. So I've got circular motion focus. I've noticed a few things about the diagram that have clearly shown I'm into that focus, and I'm going to look at the very first question. So this is anticipating anyway, anticipating and focusing. Draw two labelled arrows on the diagram above to show the velocity and acceleration, so it's two things. I'm anticipating I'm going to have to answer two things, and well, it's already said two, so maybe I didn't need to anticipate, but you get the idea, of the discus at the instant shown. So, alright, I've noted velocity, I've noted acceleration, and I've noted I've got to draw two things related to that. I'm going to double check and reread the question, because sometimes as I'm noticing things like velocity and like acceleration and circular motion, I kind of forget what aim of the question is. It's not so much of a problem on these shorter questions, but on longer ones you can lose the plot pretty easily, so it's good to go back and summarize the paragraph. Anyway, draw two labelled arrows on the diagram to show the velocity and acceleration of the discus at the instant shown. Well, I've already started one, but I'll redraw it. That's the velocity. And the acceleration is always towards the centre. Should show the vectors with my wiggly line underneath. And it should be right angle between them. Okay, so those are just straight up concepts that you can memorize. There is a lot of understanding behind them, but that's not what this video is about, so I'm going to keep moving on. B. James releases the discus at the position shown in the diagram below. So I've made a, I've got to remember that we're dealing with this one now, not the one above. In fact, in your mind you can even draw these sorts of symbols that I'm doing to help you focus, or deliberately make your eyes look there to get your brain working right. Now he says he releases the position shown in the diagram below. If I'm anticipating correctly, I'm going to anticipate where the direction that's going to go. So I've got this here, that's the centre, there's a radial direction where he releases it. It's going to travel off in this direction. Okay, now I'm anticipating they're going to ask me a question about that. I've said that before. Draw an arrow showing the direction of the discus travels. Well, look, we've already done it in our mind, so we just put it down there for real. And then we have to explain why the discus then travels in the direction we have drawn. Okay, there's a lot of things we could say about this. We've got an instantaneous velocity going in that direction, and it's too simple answer if we're thinking about that. We need to anticipate, get in the mind of the examiner. What are they trying to get across here? Well, circular motion, one of the big fundamentals is that centripetal force and that acceleration. So you're anticipating, you're thinking about all of these things. I'm drumming it in. It's probably going to get boring, but it helps answer questions. It's not enough just to say that there is a constant or instantaneous velocity at a tangent to the surface of the motion of path, of the circular path. You also have to think what's missing. So you're comparing the motion after he's let it go to the motion he has. And that explains a lot more than if you just say he lets it go and it's going in the direction it was going. You have to say why it's not going in the circular motion direction. And the examiner, who's given this question a little bit vaguely, has been expecting you to give a detailed analysis of circular motion and the key principles of circular motion in comparison to what you don't have of that circular motion when you're going in just a straight line. So what's missing is there's no centripetal force to cause a centripetal acceleration. And that centripetal force changes the direction of that velocity, and because it's fixed in the centre, it just travels around in that circular path. The next instantaneous velocity is still tangential to the surface. Centripetal force is still towards the centre, causing an acceleration which changes the direction of the velocity, and so forth. Okay, velocity is a vector, change in direction, not magnitude. Anyway. Question C. Before throwing the discus, James swings it around in a horizontal circle at a constant speed of 11 meters per second. So that's a speed, that's a vector, that's a scalar. So that's the instantaneous velocity at whatever angle it is. But just remember that that's 11 meters per second. The mass of the discus is that, and at one time he applies a horizontal. I'm thinking this is going to be a mathematical question. Before I even get to it, I'm anticipating again that it's going to be a mathematical question because I've got all these mathematical clear numbers. There's haven't been any numbers so far. So the mass of the discus, 2.1 kilograms at one time. He applies a horizontal force, 290 newtons. Calculate the radius of the disc's circular path. Well, we've seen this before with mathematical questions. You just apply, write down all of what you know, any formulas that relate to them, and do it. So your speed is 11 meters per second. Your mass 2.1 kgs. Your force being applied is 290 newtons, and it wants to know the radius. And what links all these together? Centripetal force equals mv squared over r. So we're trying to find the radius, so we'll go r equals mv squared over fc. Just plug those numbers in, press equals, and then out it comes. Okay. I will talk more about this anticipation. This probably wasn't the best example for it, but you get the idea, I think.